All right, welcome back. So this set is about finding transformations when you've been given a equation or a function that's been changed, and we need to read what the transformations are and write a list of what they would be. So there's two ways to do it, and we'll go through both of them. So the first, we're just going to work through the set, and the first book, not the first book, the first example is we've got this base function, so just an x squared, a parabola, and it maps to another function that has been transformed by these changes. So most simple is we can just read the changes from the parent function, from the transformed function. So it's got an a value, a h value, and a k value, h and k, and we'll just describe them. So it's dilation factor of 2, and we have to describe what it means or where it's from, and it's 2 from the y-axis. No, it's from the x-axis, which is a vertical change. All right. The h value is 2 units to the left, and the k value shows 3 units up. You could use fancy language there. The book will often say, instead of left, it will say 2 units in the negative direction of the x-axis, which is a bit fancy. And you don't need to do that. And up, they'll often say, is 3 units in the positive direction of the y-axis. So long as you're very clear about how many units and which way it goes, there's no need to say use that language. All right. So that's method number one. And what we're going to do now is look at how we can use what we've learnt previously, so the image points and so forth, to find out what the changes are. And having done it by inspection, we should be able to do it or work out the answers fairly easily. So the first thing is that we rewrite the rule, but instead of y and x, we use image of y and x, because you might remember in previous sets that was where we'd get to at the end. We'd have a rule that had images in it, and but when we got that final step, we were able to just leave the image off and everyone would assume that it's been transformed. So the first step is to do this. Then we're going to rearrange the equation to get all the changes outside the brackets together and all the changes inside the brackets together. So the rearranged equation will look like this. All right, and the reason we do that is because now the changes are neatly grouped according to which variable they affect. So now I have two sides of the equation. I'm going to go this y equals the image minus 3 over 2, and x equals x image minus 2. All right, notice that the brackets with the square don't need to come, because this is just the changes that have affected it, and the brackets with the square are part of the function, so they don't need to come with us. Then I'm going to rearrange both of the equations to get y image and x image by themselves. So this is essentially the opposite of what we did in the previous sets. All right, so this is going to become 2y plus 3 equals y image, and this one's going to become x plus 2 equals image. All right, and then I'm just going to read the transformations from these equations. Okay, so just like we worked out before, this is a dilation. It happens to the y value, which means it's from the x-axis, and it's a factor of 2. And if we compare this to what we found up here, we can see that's the same thing. Then we've got a translation 3 units, and it happens to the y value, so which means it's a vertical change, and it's 3 units positive, so it's 3 units up. Compare it to what we had over here, the k value, and that's the same. Moving over to the x value, we can see the change is 2 units, and it's positive, which means it moves that direction, so it's 2 units right. Compare it to the h value, and there you have it. We've found everything that we had confirmed in the first place, but we've done it using a little bit of algebra. All right, and the reason it's so important to do this is because so for some functions, you might remember that when you have dilations that happen to the x, you have to read them as the opposite. And if you don't take this approach, you could make that mistake very easily when you do it via inspection. All right, so another example from the book is y equals the square root of x maps to a transformed function root 5x minus 2. So again, we'll see if we can read them via inspection. We know that that is the other dilation factor that happens to the x, so it's a horizontal change. You might remember that it had to be read as the inverse over of it, so it's a factor of a fifth that happens from the y-axis. Oops. This one here was the h value, and it's a negative, which means it's 2 units right. Okay, so we'll keep those in mind. We'll park them over there, and then we'll confirm using the algebra. So the first step is to rewrite the equation using the images, because if you remember, that's where you'd get to when you created the new transformed equation using the transformations. Then we're going to group all of the changes according to whether they're inside the square root sign or outside the square root sign, which you can see they're all inside, there are none outside. So I'm going to have y image equals y, and x image equals, oh sorry, not x image, x equals 5x image minus 2. Then I'm going to rearrange this one to get x image by itself. So it's going to become x plus 2 all over 5 equals x image. Now let's read the transformations. We can see here that we've got, this is the dilation factor. It's been divided by 5. All right, so we've got a 1/5 dilation factor, and it happens to the x value, which means it's from the y-axis. So if we go back to what we did by inspection, we can see that that is the same. So we've managed to get that one done nicely. What we can also see here is a plus 2, but don't forget that it's a fraction over 5. All right, so what that means is that the translation is actually 2/5, and it seems to be positive, which means it's in the right direction, so it's moving that way. Now, if you go back to what we did by inspection, we can see here that we assumed that it was 2 units in the right direction. So somehow we've come unstuck. All right, now this is correct. The algebra way is correct. What we've done by inspection is where the mistake was made, and I'll explain the mistake. So your first point of call is to relook at the function, and you know that the function is, or should be, written in this form, plus k. Now there is no a value at the front, there is no k value at the back. What we're looking at here is x minus h. Now what you may not know is that x minus h cannot have a coefficient in front of the x. So, and if there is, you have to make sure that you factorize it out. So let's call it n. We have to have it looking like this, all right? So that when the brackets are removed, it will look like nx minus h, but that is not the translation. The translation needs to be divided by n so you can read it, because it needs to look like this with no coefficient of x. If you do have a coefficient, you have to factorize it out. If we were to factorize out the 5 from the x minus 2, you would have bracket x minus 2/5, and you can see there that what we should have read was 2/5 in the direction of the right, all right, not 2 as was shown up here. All right, so important information there. If you have a coefficient of x, you cannot read the h value until you factorize it out. All right, so now we're going to deal with a different kind of question that looks at a transformed function and how we get it back to an original function. And there's a rather straightforward process which I'll explain, and it's just a matter of changing your perspective to making this the required goal, rather than starting from this and working out what the changes were and reversing them, which can take a little bit longer. So your first step is to think about this one as being the desired point. All right, so this is the end result, and that's going to be the image. So y image equals 1 over x image squared. All right, so then we'll go back to the first function, and we'll rearrange it so that all the changes are that are inside the brackets stay inside the brackets, and all the changes outside the brackets are on the same side. So you should know this. It looks like that because I've moved the 6 become a negative, and then this number on top here, I wanted that to be a 1, just like it was in the desired function. So I had to divide by 3. When I divide this by 3, I divide the other side by 3 as well. Because I'd moved to the 6 first, it happens to the entire left-hand side now. All right, so now this function we've started with, which was a rearrangement of that one, looks more like this one. We have y on one side and x on the other side. So now we can just compare sides. So I have y minus 6 over 3 equals y image. Now don't forget, the image in this case is the end result we want to get to, and we want to get to 1 on x squared. And then I have x minus 1 equals x image. All right, I didn't need to put the brackets there. I don't know why I did. Ignore those. So now because these two equations are written as y image and x image, that means that this is the final result, and whatever happens on the left-hand side are the transformations that have happened to take it to the final result. So we can just read them off. So that's a 1/3, a factor. It's a dilation factor of a third, and this is 6. So if we were to dilate this by a factor of a third, it would have to be from the x-axis because it happens to the y value. But if I was to dilate this first, you could see that taking a third out of there would make this a very big number. So that has to be the last change I do. So the first change is going to be this translation. So it's going to be 6 units left. 6 units, sorry, not 6 units left. It happens to the y value, so it's 6 units down. All right. Then this change can happen, and it's 1 unit. -1 is left, or that way, and then this third can happen. So it's a 1/3 factor from x-axis because it's happening to the y value, which means it's the vertical change. So your 3 changes in order are the translation in the 6 units down, the 1 unit left, and then the 1/3 factor from the x-axis, because if it happens first, it will change this translation. All right, so we'll have a look at one more example, and this is an example of a parabola with these transformations that's being mapped to the original function. So again, we'll call this one the image. So it's going to look like this. All right, and we'll rearrange the left-hand one, this one here, to be all the transformations on the left-hand side, and then anything inside the brackets can stay there. So it's y minus 6 equals 5x minus 1 squared. All right, so now we can just compare spots, and we have y minus 6 equals the image, and 5x minus 1 equals the image. So from there, it's just a matter of writing down what transformations will take us to this point. So the first thing, all right, that and this might be a little bit confusing, is that this dilation factor has to happen first, because if it doesn't happen first, that will change to a factor of a translation of a fifth. So first one is we're going to dilate it by 5 from, and which direction do x dilations happen in? If they happen to the x, it's from the y-axis, because they're moving that direction or that direction. So we're dilating it by a factor of 5, followed by a translation of 6 units down, followed by a translation of 1 unit left. All right, so this process of adjusting which function you think is the second and first, or the original and the transformed function, is alleviated a lot by the fact that if you change your ideas to being just the basic function is the image, then you can just read the transformations directly from this equation here. All right. What you do have to remember is that, probably a more simple way to put it is, dilations from the y-axis have to happen first because they affect the x variable before anything, and dilations from the x-axis have to happen after translations because they also affect this number here. All right. Brackets and things will change that, so be very careful about what you're looking at in the parent function. but make sure you do think about it. And if you're in doubt, do a quick sketch and see if that changes things. All right, so to note, or to finish off, please make sure that you get used to this image notation here, because it will make your life a lot easier with questions like this.